So I'm just going to talk to you a little bit about kinetic energy, gravitational potential energy, and work done. So the concept of work done is moving the point of action of a force. So work done is the moving of the point of action of a force. And we can quantify that. We can give that, do that as a calculation, express that. So the work done, which you can write as E for energy or W for work, is the force multiplied by the distance, where W is the work in joules, F is the force in newtons, and D is the distance. And it needs to be the distance in the direction of the force, or in the exact opposite direction. Moving at 90 degrees doesn't make any difference. Okay, so that's work done. Now, an example of work done is you can do work to store gravitational potential energy. So gravitational potential energy is the work that is done by moving a weight. And a weight is a mass times g. So the weight of an object is mass times g. So actually you can express GPE as GPE is the weight, which is mg, multiplied by the change in height. So you may see the similarities. Mg multiplied together, that's the force, so F. So mg is equivalent to F, and then the change in height is equivalent to a distance. So you've got delta H is the change in height, mg is the weight, where m is the mass in kilograms and g is the gravitational field strength, which on Earth is usually around about 10, and then GPE is the energy in joules. So that's the energy in joules. Now, the final energy we need to be familiar with for this exercise is KE, and that's the energy due to an object's mass and its velocity. And the kinetic energy of an object is equal to 1/2 of its mass multiplied by its velocity squared. Lots of people miss out the half, lots of people miss out that the velocity is squared. So that is the basic equation. You need to be able to rearrange these, and the more you practice, and if you show you're working, then being able to rearrange it will get easier and easier.